Okay, we're solving a trig equation. This is largely revision of what you did in Core 2, but now we've got one of the new flavoured trig functions. We've got a cot. So the first thing we do is we decode it, okay? Now very often, for identities and stuff, the best way to decode cot of something is into cos of that angle over sine of the angle. But here, we want to find out what the 2x is. We just basically need to undo the cot. And it's going to be best if I just work with one trig function. So I'm going to turn it into its reciprocal form. So what does cot of 2x mean? The third letter is t, so it's 1 over tan of 2x. Okay, so 1 over tan 2x equals minus 1. But that means that, well, the reciprocal of minus 1 is minus 1. So this tells me that tan of 2x equals minus 1. Okay, so now it's just like the way you did these equations in Core 2. Now I like, when I've got something other than x inside the trig function, to or sometimes you can call it a name, so we could call it alpha. We definitely need to set up the range of values for 2x. So if x is between 0 and 360 degrees, then 2x is going to be between 0 and, I'm doubling everything, so this will be 720 degrees. I need to do this to make sure I get the correct solutions. So I'm solving tan of alpha equals minus 1, because I'm letting alpha equal this 2x. Okay, so what do I do now? Well, now I've got tan of something is minus 1, I can just do an inverse tan, and this will give me my first solution. So my first solution, remember there are multiple solutions to trig equations. So my first solution is going to be alpha being inverse tan of 1, which I can do on my calculator, but it's one of those exact ones. This one happens to be 45 degrees. I am in degrees, always check. Are you in degrees? Are you in radians? Okay. This one says degrees, so I'm in degrees. So inverse tan of 1 is 45 degrees, good. Now I need my second solution. Now this is where you can visualize a tan graph, or you can use other methods, okay? But whatever method you use, you need to know that the second solution is going to be 180 added to this first solution, so it's going to be 225 degrees. So I'm assuming you've got a method for your Core 2 trig equations. Okay, if not, get to math support and make sure you've got these kind of equations completely taped. All right, so I've now got two solutions. There may be more, because remember, the other thing I can do is I can get my 360 repeats of these solutions, and I must do this before I go back to x. So I'm working with alphas, okay, so I can do 360 repeats, and since alpha can go up to 720, I need to. So alpha with 2x, which is alpha, could equal, well, it could be the 45 degrees, okay, or it could be a 360 repeat of that, which add 360, you get 405 degrees, so that should be a comma, it's a list, and then it could be 225 degrees, but it could also be the 360 repeat of that, which is 565 degrees. So I actually get 4 possible solutions for 2x. More 360 degree repeats will take me outside this interval. So x will equal, okay, divide each of these by 2, 22.5 degrees, or 202.5 degrees, or 112.5 degrees, or 282.5 degrees. And I'm done. Okay.